So this section is dealing with measures of central tendency. Now you'll note that I have everything already up here. The reason why is because I previously recorded this, but my mic was not working, so I had to go and replace it with a new mic. So instead of erasing all my work, let's just go ahead and go over it again. So the first thing that we want to talk about is the mean. And the mean of the data set, which is written as mu, the Greek letter, or x bar, is found by, now this fancy little thing here, this is capital Greek sigma. This just means add them up. So the sum of all of our data points over the number of our data points. So the sum divided by the total number. Okay. So as an example, if we look at the set 3, 7, 2, 5, 9, and we want to find the mean, well, we add them up. 3 plus 7 plus 2 plus 5 plus 9 divided by 5. So add these all up, we get 26 divided by 5 is 5.2. Okay. So if you're trying to find the mean, add them up and then divide by however many there are. Okay. Now, sometimes it'll ask you to find the mean of a frequency distribution. If you're asked to find the mean of a frequency distribution, then what you're going to do, instead of adding up all your data points, you first multiply the value times the frequency. So that's this x times f. So for this one, 0 times 2, 1 times 1, 2 times 3, and so on. So you multiply all of these together, and that tells you your overall results. Then you add them all up, and that gives you what your sum of your data is for that frequency distribution. Then you divide by however many there are. In this case, if you add up all of these, you'll note that there were 151. Okay? So much the same as finding the regular mean, the only difference is you're multiplying each individual entry times its frequency. Okay? Then the median is the next thing we want to talk about. The median refers to the middlemost entry. Okay? So we have two cases when we're talking about the median. Our first case is when we have an odd number of data points. Okay? If we have an odd number of data points, then there will be a single middlemost entry. Our second case is when we have an even number of data points, in which case there will be two middlemost data points, so we have to average them. Okay? Now, before we determine which are the two middlemost, the first step we always have to take when finding the median is to arrange from least to greatest. Okay? So for this example, 3, 7, 2, 5, 9, the first thing that I do is I arrange it from least to greatest. So the least entry is 2, then 3, then 5, 7, and 9. Since there are an odd number of data points, it's just the one middlemost, in this case, 5. Okay. Then as another example, 1, 7, 3, 12, 9, and 8. We arrange that from least to greatest, 1, 3, 7, 8, 9, 12. And then to take the median here, because there are an even number of data points, we have to average the two middlemost. So 7 plus 8 is 15, divided by 2 is 7.5. Okay. Now, a question you might have, or a question I get asked quite a bit, is when would we ever use the median? Why would we use the median when we can find the average? And the answer to that is we will use the median whenever individual data points will skew the overall picture of what's going on in the average. Okay? So for example, let's suppose that we are looking at an island with 100 people on it. Okay? So there are 100 people that live on this island, and I want to list how much each person has for their net worth. The first person has $0 net worth, second person $0, third person $0, and so on, all the way until the 99th person who has $0, and then the 100th person has $100 million. Okay? In this case, the average worth on the island is $1 million. But ask yourself, is $1 million reflective of as to what life is like on that island? Well, the answer is obviously no, because this is nothing like what's going on. Most people here are living in abject poverty, so instead we should use the median, which tells the story here, which would be the average between the 49th and 50th data points here. And we'll note that that would be $0. And that's much more reflective as to what life is like on that island, okay? So if you have individual data points which might skew the overall picture, it makes more sense to make use of the median rather than the mean there, okay? The last thing we want to talk about is the mode. The mode is the most common data point, okay? Now, it's possible that you can have one mode, more than one mode, or no mode, okay? And for this example, we look at a set 1, 1, 2, 3. 1 occurs more than any other, so that means it's the mode. Our second option is where we have 1, 1, 2, 2, 3. We note that 1 and 2 both occur the same number of times, but 3 occurs less. This tells me that 1 and 2 are the mode, so my mode is 1 and 2. And then finally, if we have 1, 1, 2, 2, 3, 3, well, all of those occur the same number of times. If your data points occur the same number of times, then that means there is no mode. Okay? Now that is all the material that I wanted to cover out of this section. Please let me know if you want to see any more examples on this section or anything like that. Note that this isn't necessarily the most computationally intense. It's just adding and then dividing, or rearranging and then finding the middle, or multiplying and then adding up and then dividing. But next section, when we start talking about the standard deviation, it will be a bit more, not difficult necessarily, but much more computationally intense. So do note that the first couple of sections may not require much effort, but don't let that lull you into a false sense of security moving forward. It's not hard, but it's kind of a pain in the butt for the next section when we find the standard deviation, okay? But as always, let me know if you have any questions. Otherwise, see you in the next video.